Good day, friends, and we are in lecture number 11, and we will continue with more examples how to rotate different kinds of objects to create some beautiful patterns. And today, I will uh, rather rotate an ellipse around the origin. So this ellipse I will of course write in the form of an equation x by say 2 whole square, x by 2 squared plus plus y by say 5 whole squared is equal to 1 is equal to 1, and you get this ellipse. Okay, so the ellipse has been drawn, and the name of the ellipse is given to be eq1. Then to rotate it around origin and by various angles, I will first create a slider as usual, that is a equal to, and you setting is of the slider, make it 1, and this you make it a large number, say 40 or so, 40, with an increment of 1, and that's it. That is the setting of a, and then we know what I have to do. That is, I have to rotate what I want to rotate, the ellipse. What is the name of the ellipse? EQ1, comma, the angle 2 pi into k by a. That's all. This is the angle by which I want to rotate it, and around which point. It could be around any point you like, but I will rotate it around, say, origin, around origin. So that point is 0 comma 0, is not, and so this is the thing. But I forgot to write, because several ellipses I want to draw, so I want to do a sequence, um, and so it will be then this one, and then you say in which range k will vary, 1 comma a comma 1. That is starting value, final value, and this. That's it. And if you increase a, it will draw many ellipses, odd ellipses. Good patterns are created. This is, therefore you can also try with other objects, interesting object, maybe a parabola, or say any small triangle, and rotate it around the origin. Of course, triangle comes as a sub-function of polygon that we have done, but you can try on your own. And then at certain distance, you can superimpose on it some circles rotating. It will add to the beauty of this pattern. I hope you got the point. For example, you can do many things, and I'll just try once so that you also try many other things. For example, you just say a circle. You say I will write in one stroke sequence, and then you say a circle coordinate of the center. So you say coordinate of the center is at 4, 0. Okay, coordinate of the center is 4 comma 0, and then the radius you say it is 1. It is 1. Sequence circle 4, 0 comma 1. But where is the variable gone? Or better, I should do what? You just first create the circle. Forget about sequence. I just create the circle. I'm sorry. You create first the basic circle, which I want to rotate. So circle, its coordinate 4 comma 0, and then comma, as I told you, of radius 1. So a circle has been created here, as you can see. And then what you can do, you can rotate this circle about origin. So it will superimpose on this elliptical pattern here. And so you just copy this instruction. You need not do so much typing, except eq1. You now give the name of this circle here, that is small c, and this circle has been superimposed on it. You can excuse me. So this also gives you a very beautiful pattern. Got the point. And if you vary A, this pattern will dynamically change. Is it? Uh, is it? So you can vary A, and for different values of A, you can sketch it. But it nonetheless gives you a variable and interesting pattern. So I have just like that superimposed these elliptical things with some circle. You can go on adding circle, triangle, and whatnot. So that is fine. So this is the thing about this part, and I will take another example of rotating things. That is, I will stop here, and this one I will, this time I will rotate a function. I can rotate any function. For example, I create a function sin x. Okay, and this sin x function is given an mf, and if you like, you can rotate f around, say, origin. By this instruction, only thing, this eq1 should be replaced by f. But it is no point in rotating a long sine wave extending uh, from minus infinity to plus infinity. So better, instead, what we'll do is this. I will first create a function over a range, and I will say if say um, minus pi, okay, less than equal to x, less than equal to pi, and then comma sin x. If minus pi x, it is the range of this, and sin x, it creates this function f. Okay, this one, it looks like if I rotate it, it will create a somewhat different pattern. So I once again duplicate this input here. I'll duplicate it. See, duplicate input here, but this time not with ellipse. I will rather change it to f, the sine function. Okay, and it has rotated around point 0, the function f. So it could be any object, including functions, which you can rotate around any point you like. For example, you could rotate the for a change. What I want to say is this: asymmetrical rotating can be done. So you have understood this, and if you play a with different values of a, if you play, oh, it is not playing. Some problem here. 2 pi k by a. Anyway, that you can try. It will take some time with sine functions. It takes a little bit more time, which I will not waste here. It has changed it to 30 now. So it takes some time because of some computational burden perhaps. Anyway, it is done. So it can also create a pattern like this, which is slightly uncommon pattern, sine wave function. Okay, so that's good. So you can try several things. So I will just delete this thing. Acha, now what I was trying to tell, I was rotating this ellipse around origin. What I will do, I will copy this instruction. See, this is how you should always do it, and this equation has been copied here, but I will say that I will make it a little less so that where is that a business? Okay, what I wanted to do actually is I wanted to go up. What I want to do. Ah, this A I'll make a little less here. Okay, A3 say. Clear. Now, and I delete this sin x business. It is taking some long time. I will delete this. Okay. So this is the elliptical pattern, and this pattern has been generated by rotating an ellipse which was vertical around the origin. Now what I will do is this: I will rotate this ellipse only, but not about origin. Got the point? I will rotate it say around any other point, say around 2 comma 0. If I rotate it, what happens? Um, hmm, I cannot see this. It is good here. Nice. Are you getting me? Now I am rotating the same ellipse, but not around origin, but around a point 20 here. Around this point, I am rotating the ellipse. And if you do like this, then you will be, and if you play here, this is nice to see that it has created such a beautiful pattern. I hope you are getting me. Therefore, it is not at all necessary to rotate everything around origin to create and try some interesting pattern, but you can rotate any object about some point. You can give a try this point around this point. If I rotate the ellipse, what happens? Nonetheless, it will always return you with some interesting pattern. That is what I wanted to highlight to you. Now you have understood this. Okay. So I have rotated a function, I have rotated an ellipse, and things like that I have done. Now, the last thing which I would like to do in the midst of all these things, since I know now the circle command, I will now do a rather common but interesting pattern can be created just by rotating points. For example, you say you delete it all here, clear all. Don't save it, and I say that um, I will create a first of all a slider. Say I'll go first. You now know these things. Slider and make it say 1 to say 40 matter. This is 40 with an increment of say 1, and that's it. And then you just produce a circle, okay, and say circle. I'll create the circle in these two ways. See, suppose it is at the origin, create a point C, and then create a point say B 2 comma 0. This point has been created, okay. Okay, then I draw a circle. I'll draw CIR slowly circle, um, circle with center at C and radius with CB. That is this radius. So I can write 2 simply here, but I am just giving another flavor of doing this. You know, segment say CB. Segment between 2 points, so C comma B, and this circle is created, is not. Now what I plan to do, I will rotate B around C and produce a sequence. That is what first I am going to do. So I will first create this. I have done previously also, but anyway, sequence, um, rotate, uh, rotate B, rotate B, okay, around point C by what angle? By a variable angle 2 pi into say k divided by a, huh? And about which point? About say origin, about origin. Origin, it is C defined, so that is there. And then comma k comma 1 comma a comma 1. You do like this, k comma, and this is 1. Sorry. Okay. 2 pi k by a, b will be rotated. A is 1. If you increase b, several points have been created. That is fine. Now what I plan to do, I'll create a sequence. I'll go to any points here created from list L1, go a particular point and draw a circle with center BC like this. Go to this point, draw a circle with center BC. Okay, that is what I plan to do. So another sequence. So here you write it. I'm sorry. So sequence. I will make a sequence of several circle whose center point will come from list 1. So L1 K center will come from list 1 and its radius will be, and what does that mean? Sequence circle L1K, and you have to write its radius, and its radius is segment 2 point. I must provide one point is L1K, and the other point is C, because I'll go to each point and draw circles around that point like that. Here another circle. That what I want to do. So I think it is okay. Circle, its center is L1K. It will come from list L1, which are nothing but coordinates, comma, segment L1K, comma, C, and K will vary from comma K, comma 1, comma A, comma 1, 1, and it is done. Okay. And if you want to remove these points, you can do that. But anyway, this is the thing what I want to tell. So it also creates a beautiful pattern here. You can remove this circle, keep it this, whatever combination you want, you can do that, and this is done. And if you vary A, it creates a very beautiful looking pattern. This I could not resist to by tell you. I do not know whether some this type of things I have done with hexagon. As the number of sides of hexagon becomes large, it will approach to this kind of thing. Okay, so that is the thing. Okay, so I will stop here today and wish you a very good day, and hope you have enjoyed this video as well. And this is the end of lecture 11. In lecture 12, I will tell something, some new topics I will start. Thank you for watching.